Question. DS. What is the value of positive integer n? Condition 1. N has only 2 and 3 as the two different prime factors. Condition 2. The number of different factors of n is 6. Solution. Let us solve this DS question using the variable approach. The two important points that should be taken note of. 1. Consider the same and different cases. 2. Exponents have no effect on the number of prime factors. Let us apply 3 steps of variable approach. Let us follow the first step of the variable approach by modifying and rechecking the original condition and the question. We are required to find the value of the positive integer n. Follow the second and the third steps. From the original condition, we have one variable, n. To match the number of variables with the number of equations, we need one equation. Since conditions 1 and 2 will provide one equation each, D would most likely be the answer. Recall 3 principles and choose D as the most likely answer. Let us take a look at each condition for the information given. Condition 1 tells us that n has only 2 different prime factors, 2 and 3. We cannot find the exact value of n, as it can be 2 to the power of 2 times 3 to the power of 2, or 2 cubed times 3 squared, or something else. Thus, this condition has no unique answer and is not sufficient by CMT2, which states that the number of answers must be 1. Condition 2 tells us that the number of different factors of n is 6. N can be 2 squared times 3 to the power of 1 equals 12, or 2 squared times 5 to the power of 1 equals 20, and so on. All with whole of 2 plus 1 times whole of 1 plus 1 equals 3 times 2 equals 6 different factors. Since we cannot find the unique value of n, this condition is also not sufficient by CMT2, which states the number of answers must be 1. Combining conditions 1 and 2, we know that 6 different factors mean that the exponents of the prime factors are 1 and 2. That is, 6 equals 2 times 3, or whole of 1 plus 1 times whole of 2 plus 1, and the prime factors are 2 and 3. So n can be 2 to the power of 1 times 3 to the power of 2 equals 18, or 2 to the power of 2 times 3 to the power of 1 equals 12. Therefore, both conditions 1 and 2 combined do not give a unique answer and are not sufficient by CMT2, which states the number of answers must be 1. Both conditions 1 and 2 together are not sufficient. This is a very good question. Remember how it is solved, and is approximately a 49-level question. Thus, E is the correct answer. Like this, sometimes the answer is E even when the number of variables is 1 in the original condition. Answer, E.